Hi, Srini. How are you?
Hello, Jer.
Hello, anything to ask?
Not Jer.
Okay.
Jer, they delayed, Jer. I think they are going to delay the exam confirm.
Are you sure?
No, because you know why, teacher? The physics and chemistry, I mean, so by right September 1 means that means by right sure. We never even finished the experiment yet, you know, Jer. And we are
You are
entering.
supposed to have it in October exam.
Yeah, but we haven't even do the experiment yet, incomplete experiments yet also, Jer. Physics, chemistry, that one also haven't finished.
Oh,
And then you have to submit the pengajian kosong to the teacher, the hard copy, and then match this one.
To worry. Leave your teacher to worry. Not our job to worry.
No, but you know what's the one more thing, Acha? The problem is right, because Talaji not sure because the exam October 4 and then they're gonna open school October 3. But then we all still in phase 1. So phase 1 also they say not sure. October 3 only for phase 2, phase 3 confirm. So don't know how they're gonna do the exam also. They never even tell the date.
Okay. We will leave it to the school to worry. This is not our job to worry. Let's just prepare for the exam. Have we done a pure inductor under checkpoint 18.2? This question, number 1.
Yeah.
Where did we stop? Any idea?
Oh, that one I forgot. I thought like you asked me to.
Have we finished 18.2?
18.2, number 2 only.
We have finished number 1.
Number 1, no, I don't know how to do number 1.
Number 1 is just memory work, only nothing much. A pure inductor is connected to a sinusoidal alternating voltage on the same time axis. Sketch the graph to show the variation with time of the voltage. So you just draw the voltage first. It's a sine graph.
Oh, it's already in the notes already there. Yeah,
it's in the book. And then current lag. Lag means the sine graph is shifted. The peak doesn't matter. It can be the same, it can be different, or voltage can be lower, current can be higher, doesn't matter. Right? It's shifted by 90 degrees, that's all. Then just draw the current graph. Right? Draw 4 quadrant. Right? From 0 to maximum, maximum to 0, to minimum to 0, that's all. And then for your power is just within that half period. The half period, there is a full cycle for that. That's all. Nothing much about that. Remember that it is, if you've forgotten, just derive it. Derive the equation, then you can draw the graph. If not, memorize it. Okay? In your book.
all right.
And alternating current of 2.5 ampere and frequency 50 hertz flows in the inductor with an inductance 5 millihenry. What's the potential difference across the inductor? How to calculate this one? You got current. To find the potential difference, you must know the reactance. DC you call resistance. AC you call reactance. How to calculate the reactance of the inductor? Yeah.
V equals to Ix.
Yeah, but how to find your V times Ix? How to find X?
Oh, X equals to 2 by FL.
Yeah, go and calculate. Right, put in your value and calculate out. And I times X. Calculate out. Okay. Okay, let's go to the 18.3. A voltage is connected across a 20 millifarad capacitor given by V equals to 6 sine 50 pi t what is the reactance of the circuit? Okay, how to calculate the reactance?
X equals to 1 over 2 pi FC.
Okay, good. Just that formula. Put in your value. 2 pi.
2 pi. Yeah.
Omega lah. Omega is 50 pi lah. It's omega. Then this is your C. Okay, out. Write the expression for the variation of current with time. So for capacitor, how to write? Yeah, how to write?
Wait, 1 minute, teacher. 2 pi F is the 50 pi. Is it? Hello?
Yeah, yeah.
2 pi F is basically the 50 pi. Right.
This 50 pi is your omega. Huh? Instead of using
2 pi F lah.
Easier, use omega.
That means the 2 pi F is equivalent to 50. That one, that's why they replace.
Right, work with omega, be flexible. Why go and make yourself confused? Or 2 pi ft is 50. You must be able to flexible to say this is 2 pi ft. So 50 pi is 2 pi f. That's all.
No, that's all I asked. Yeah, that's all.
Next part, you need to know that the current leads the voltage by 90 degrees. So it's a cos graph. That's all. Find your I naught first. 6 divided by the reactance. And write the equation. That's all. Any comment?
Oh, so why is it 18.8 cos 50 pi t? Huh?
You have to find I naught first before you can write the equation. Okay.
Okay.
A capacitor with capacitance 5 is connected to 12-volt supply. What's the maximum charge on the capacitor? Okay, your next class will be Saturday. Remember, I'll give you your first quiz.
Yeah. First quiz.
Electrostatic.
Oh, the quiz is electrostatic.
Electrostatic, half an hour. And then the other half hour, I'll go over the answer with you. Just a revision. So, how to do this question? Remember, this is root mean square. Just calculate your peak voltage. 12 volt is root mean square. Yeah, how to calculate?
Q equals to CV.
What do you say?
Q equals to CV.
Q equals CV. How to find your V? How do you find your maximum voltage?
12 square root 2. I mean, you take the 12 volt one and then times square root
2 peak voltage. And then use your Q max is CV naught. Multiply them out. Get your answer. Okay, how to calculate maximum energy?
1 over 2 CV square.
Okay. 1 over 2 CV naught square. Put in your value and calculate out. Okay. Any comment or anything not clear?
No, okay. I'm okay.
Okay, let's go to the next one. 18.4. A filament lamp and an inductor are connected in series with an AC generator. If the frequency of the AC generator is increased, does the brightness of the lamp increase, decrease, remain the same? Explain your answer. Yep. Got resistance and reactance in series.
When frequency F increases, impedance X increases, current in the lamp decreases, power dissipated P equals to I square decreases, brightness of lamp decreases.
Brightness decreases, is it?
Yep.
Okay. Basic is formula, that's all. So as the frequency increases, your reactance increases. So the total impedance also increases. So the brightness, the current will decrease. Right? Current is the most important because it will contribute to the power. So your brightness will decrease. Right? So as brightness of lamp decreases, the frequency increases, the reactance of the inductor, and thus the impedance of circuit increases, decreasing the current to the lamp. Okay?
Okay.
Okay. 3 kilo ohm resistor and a capacitor are connected in series with a 12 volt, 50 hertz AC supply. The root mean square current is 2.5 milliampere. What is the root mean square voltage across the resistor? How to do that?
Oh, why the thing such? Wait, answer. RMS voltage. V goes to IR.
V equals IR as well. Right? Remember this root mean square value, that's all. And put in your value, you have your current, convert it to ampere, times your convert to ohm, 10.5 volt. Sketch a phasor diagram for RC circuit. How to do that? Yep, how to do that?
Sketch a phasor diagram. Right arrow, down arrow, and then like what you call that, the V, the one we do in maths, but like between that. Yep, that one.
Yeah. Your resultant, right? Your capacitor is down here. There's your capacitor. Okay, the 12 is here, the resultant. Deduce the root mean square voltage across the capacitor. How to do that? Yep. Just look at a triangle, that's all. That's why they ask you to draw. Use your vector diagram. How to find VC?
Oh, VR square plus VC square.
Say again.
I mean V square minus VR square root. Yeah.
Okay. That's all. Good. Phase angle. You can use tangent, you can use cosine, you can use sine, up to you. Your choice there.
Theta equals to tan -1 VC over VR.
Okay, you can use cos if you want to. So cos is right, adjacent 7.5. Hypotenuse 12 volt. What is the impedance in the circuit? How to calculate the impedance in the circuit?
V equals to IZ.
Okay, Z is V over I. Put in your value for, there is your 12.
Too many formula to memorize, lecture.
That's the reason you have to do the question. Then you can force it in. That's what the math way is doing. Every little bit teach you, you got.
Wait, but then physics, will they ask more to explain questions?
If you don't do the work, that's all. There's so many formulas,
No.
you know what to use.
And does physics they ask us to explain more, so, or they ask us to calculate more? Which one?
You should be able to do partial paper now. Next week you'll be doing partial paper, so you will know already. There will be a define, there will be derive, there will be graph. Then after that, a lot of calculation. You already gone through the first semester, so you should know already how the paper look like. Most of the thing are calculation. That's why if you don't do the calculation, you won't do well because you don't know how to solve the problem. Okay. Find the capacitance of capacitor, how to do that.
Find the capacitance of the capacitor.
First, find the reactance of a capacitor. That's the reason why.
So X equals to 1 over 2 pi FC.
Right? First, you got your VC, you got your Z, then find your XC, VC over I. After that, use your X is 1 over 2 pi FC. Yeah, calculate your value. X you already calculated there. X 2 pi 50. Take the C across, cross multiply, and calculate out. Okay.
Okay.
That's the reason I keep on asking you, must do homework. It's basically a lot of calculation. That's why this book is good, because it gives you a lot of calculation. 6 volt, 30 hertz supply is connected to a 2.8 ohm, 0.66 millifarad capacitor, and millihenry, 20 millihenry inductor. No, sorry, what am I doing? Okay, you should be able to calculate out. Sketch a phasor diagram to show the phase difference between potential difference across resistor, capacitor, inductor. Okay, that one we have done in class. You should be able to draw that. Use the current as horizontal. That's your VR. That's your VL. And that's your 90 degrees. That's your VC. Can calculate the impedance in the circuit. How to do that?
X equals to 1 over 2 pi R FC.
Impedance.
Oh,
the impedance in the circuit.
X equals to square root R square plus bracket XL minus XC square.
Right, you have to find your XC first. Put in your value. 2 pi, F is 50. Sorry, what have I done? Sorry. I've changed the question, isn't it? It should be, yeah. It should be 50.
So I go toilet for all, sir.
Okay.
Hello?
Yep.
Sorry, Che, yeah. Where was I, Che?
We're supposed to calculate the impedance. So impedance is basically the total resistance. So if the DC circuit, you just add all the resistance in the circuit. But AC is slightly different. You have to calculate the impedance of each of them. XC and your XL, reactive impedance, and then add all of them together. That's all. Remember, you don't add, you have to use it as a vector. So your XL minus XC, square that and R square. You have to memorize the formula. Okay.
Okay. Yeah, that's it.
What is the root mean square current in the circuit? How to calculate that?
V equals to IZ.
V equals IZ, okay. V root mean square over Z. You calculate your Z already. Put in your value. Find the root mean square potential difference across one, fancy. One, the resistor, the capacitor, and the inductor. So how are you going to do that? Yep, how are you going to do that? For the resistor.
V equals to IR.
Just use all this formula, that's all. Instead of IR, IX. Okay, out. Then VC is IR root mean square times XC. Put in your value. Root mean square, we got 1.9. XC is 4.82. And then VL, V root mean square is 9. Okay, slight differences in answer expected lah, because sometimes you mix your 2 and 3 significant figure together. It's best to work with 3 lah. And then if you want, round it off to 2. Okay, anything not clear?
No, I'm okay. Okay.
Yeah, okay, let's carry on then. Okay, we have completed this one. Let us go to focus those that we have not done.
So we finished the entire syllabus already, right? So,
Yeah, we have finished already. That's why we are going to go to past paper already. Start with your electrostatic quiz. So this one you have to tell me which one you have not done. I think we have done all the multiple choice. Structure one we have also more or less.
structure first.
Structure question, which one you haven't done yet?
I think everything. Not yet touch yet.
Done already.
I don't think so, lah, Che.
Okay, if you haven't, we will do it. No problem with me. Okay. Number 1, an alternating current I equals I naught sine omega t is applied across your inductor or reactance XL. What is meant by reactance XL of an inductor? Yep.
Reactance of an inductor is the opposition to the flow of AC of the inductor.
And then also give the formula. Reactance is the ratio of the peak voltage to peak current is the opposition of the inductor to AC. Okay. Derive the expression for reactance of the inductor. How are we going to do that? Yep, how are we going to do that? What formula to use?
I equals to I naught sine omega t.
Say again.
I equals to I naught sine omega t.
Why do you start with that? You're supposed to use this formula. Start with the back EMF. And then start with your, that one is given. Yeah. Your V equals to V naught sine omega t. Right? Just put your Faraday's law. That's all. Your Faraday's law. Integrate it. Right? Integrate it. And then your derive the expression for reactance. Then define your reactance. Sorry. Forgotten to. I think you find it easier. This is the normal method lah, but you find it easier to use this method, I think. Yeah, where is it? Use this method because they have given you the formula. They have given you the formula, this formula. So you start with this formula easier. Use the Faraday's law, V equals to I di dt, and then differentiate, that's all. That one is faster lah. Right? Rather than normal derivation. Okay with that? Right? Yeah, okay, we can carry on. Okay, let's go to part B. Right? They didn't ask you to go this way lah. Okay, that's the reason why I say, since they have given you, use that way easier, faster. Straight away, use this formula. And then that is your V equals to Li, and then differentiate this one. Okay. Right? That's how you get your XL. Okay. XL is V naught over I naught. And then from what we have got, this is your I naught. Okay, let's go to part B. I naught is 2 ampere, L is 58 millihenry, omega is 314. Find the peak voltage. Okay, how to find the peak voltage? Yep, how to find the peak voltage? This one should have done at home already. I must find the reactance, isn't it? Reactance of L. 10 minutes time, you have to stop already. Okay, XL, 2 pi FL, put in your value. Right? Omega, 2 pi F is omega, given you 314.
Yeah, I thought we already did this one just now, sir.
This one done already.
Yeah. No, the B part not, sir. B part not, sir.
Have we or not? I thought we have done
No,
it.
B part only, B part. The 1A, 1 and 2 we did already. The B part haven't. Yeah, B part, sir. One, sorry.
B have done already.
No, B haven't done. A done already.
A done already, yeah. Now we are doing part B.
Yeah. Sorry. I thought like never do yet. That's why.
Right? Find the reactance. Then V naught. Peak voltage is I naught times your XL. That's all. Put in your value for reactance. Then peak instantaneous power. Right? That's your formula. Right? Can multiply it out. Or you can remember it, go ahead. Right? If you can remember the answer, basically we are interested in half the peak value, half V naught I naught, that's all. If you can remember, use it. If not, derive it. Put in your value, half V naught, there's your V naught, there's your I naught. Sorry, I naught is here, 2, and then get your answer. Okay.
Okay.
Any comment? If not, let's carry on.
Let's carry on.
It's still got a bit of time, might as well use it. Hey, what am I doing? Oh, number 2. Forgotten to remove that. Number 2, we have done already, more or less. They are repeating, that's all. Okay, number 2 is given already. We are done already. Derive the expression for reactance of a pure inductor in terms of inductance, frequency, and source of current. Then you can assume this one. Easier, you can assume this one. Then just V equals to L di dt. That's all. That's your Faraday's law. Then derive it. Differentiate it. That's what we did. That. Then this is just your V naught. This is your V naught. And we find your reactance, V naught over I naught, L omega. Okay, and AC contains a pure inductor and inductance 0.45 Henry is operated by a power supply of peak voltage 110 volt, frequency 50 Hz. Determine the peak current of the inductor. How are you going to do that? Yep, what should I do?
I equals to V over 2 pi FL.
First, you have to calculate your reactance first. Okay, 2 pi FL. We never calculate out. Then I naught is V naught over XL. Okay.
Okay.
Peak power. As I said, you can remember the formula, use the formula, you cannot derive it. Right? It's half V naught I naught. Put in your value for I naught and V naught. Then calculate out. Okay.
Okay.
Let's go to number 3 then. Right? Number 3, nothing much. The current I of the AC supply is represented by this formula. That's all. Draw the current. Draw the graph on the same axis. On the same time axis, the graph of I against T. We've done that. I against T. And then I square against T. Right? Square that. That's all. Remember, it's a sinusoidal, no sharp point here, no sharp point here. Right? It's sinusoidal again. It's just like this one pushing up, except the frequency is double. That's all. And then what is the average value? Average value is 0. What's the average value for one complete cycle for I? I is 0. And then for I square is just half I naught. That's all. Can?
Okay.
Okay. a coil which has resistance 8 ohm and inductance. I think we'll stop here. Give 5 minutes break. Then we carry on. You can try the other question if you want. You don't want to go for break.
Okay.